Intro to Sequences and Series. A sequence is a pattern of numbers that is either finite or infinite in an ordered list. Finite means that the sequence ends, like this sequence has 4 terms. And infinite means that the sequence goes on forever, like the counting numbers 1, 2, 3, 4, and then 5, 6, 7, 8, etc. These 3 dots at the end let me know that that sequence is infinite versus this one has just a finite number of terms. Go over some vocab here. Terms are the numbers in the sequence, like 2, 4, 6, 8, 10, 12. This 2 would be the first term, 6 would be the third term, etc. N we use to tell us what the number or where the number is specifically in the sequence. Like for the first term, n equals 1. That tells me the first term is 2, that's n equals 1. A sub n is which term in the sequence. For example, a sub 1 is the first term in the sequence. If I said a sub 6, that would be the 6th term in the sequence. If we look at our example, a sub 6 in this example is 12. So, like I said, we use a sub 1 for the first term, and we use a sub n minus 1 for the previous term. So those are just superscripts, and then we are going to generate a general rule. This is rule that you can use to find any term in the sequence. So our example on the top here, our general rule is 2 times n. So you can see my first term, a sub 1, is 2 times 1 is 2. My second term, if I do n equals 2, 2 times 2 is 4. So the general rule, I can generate any term in the sequence. So I can find the 100th term would be 200 in that sequence. So let's practice finding some terms in a sequence. I'm just going to do the first 4 terms instead of 6 because it does get a little tedious. So if this is my general rule, a sub n equals 5 minus n, I can find the first term, a sub 1, by plugging in 1 for n, which would be 4. My first term would be 4. Find my second term by plugging in 2 for n. It would be 3, and denoted by a sub 2. My third term, or a sub 3, would be plugging in 3. My third term is 2. My fourth term in the sequence, I would get by plugging in 4. So my first 4 terms are 4, 3, 2, 1. And I could continue that sequence on using that rule. And those 4 terms are denoted by A1, A2, A3, and A4. So if this one is my general rule over here, if I just find my first term, again, by plugging in 1, 5 to the first is 5. Second term, a sub 2, plug in 2 for n, 5 squared is 25. Third term, plug in 3, 5 to the third power is 125. And a sub 4, 5 to the fourth power is 625. So the first 4 terms in this, using this general rule, would be 5, 25, 125, and 625. And I could continue to find more terms if I'd like. So just practicing using these general rules will help us be able to create the general rules when we can recognize sequences later on. So sequences are patterns of numbers. So if we can recognize them, we can write rules for them, and that can help us make predictions. So I'm going to do the first 4 terms again. For the one on the left here, we'll do this number 1, number 2. For number 1, first term, plugging in 1, 5 plus 1 squared. So 5 plus 1, or 6. Second term, 5 plus 2 squared, be 5 plus 4, which would be 9. Third term, 5 plus 3 squared, be 5 plus 9, which is 14. And the fourth term would be 5 plus 4 squared, which would be 5 plus 16, which would be 21. So we have 6, 9, 14, 21 are the first 4 terms of that sequence, or that pattern of numbers using that general rule. Number 2 uses our a sub n minus 1. Remember that a sub n minus 1 stood for the previous term. So this is what we call a recursive rule, which means it has to be done in order. It uses the previous term. So if I want the first 4 terms, it has to give me the first term, where to start. The second term then, a sub 2, if I plug in n equals 2, I'm going to get a to the n minus 1 plus 3. Well, really, that's a1 plus 3, and a1 was 4. So I could substitute 4 back into here. So 4 plus 3, my second term will be 7. Then if I want my third term, a sub 3, it's the previous term, the a sub n minus 1. So if I plug in 3 minus 1, you can see that's a sub 2 plus 3. So really I want the previous term or the second term. The second term was 7. So the second term plus 3 is 10. So a sub 3 is 10. A sub 4 equals the previous term, which is 10, plus 3, which would be 13. So the first 4 of this sequence would be 4, 7, 10, and 13. So the previous term plus 3. Writing general rules is a little bit trickier, but we have to figure out what the pattern is and then figure out how to relate that pattern to our term in the sequence, what number terms. So you remember this is, if we have n equals, this is n equals 1, n equals 2, n equals 3, n equals 4, and this is a sub n down here. So this is a sub n of 1, a sub n of 2, etc. So if you look at the pattern here, we did a general rule with this pattern before, 5, 25, 125, 6, 25. And if you remember, those are all powers of 5. So our pattern, we're keeping 2 on the top, and then on the bottom, it's powers of 5. And the next term then, I can make a prediction would be 2 over the next power of 5 would be 5 to the 5th power, which is actually 3,125. So that's my prediction for the next term. Now, writing the rule, we have to look at our n terms. Notice how n equals 1 for the first term and 5 to the first on the bottom. So our rule is going to be, we're going to have 2 on top, and we're going to have 5 to the n power on the bottom. So just see how that works. A sub 1 then is 2, 5 to the first power, or 2 over 5. The third term would be 2 over 5 to the third, which is 2 over 125. And notice how those match our first and third term from our sequence. So I had to really use the n equal 1 numbers and our pattern. So over here, if n equals 1, a sub n equals 3. If n equals 2, a sub n equals 5. N equals 3, a sub n equals 7. If n equals 4, a sub n equals 9. Now you might be thinking that you're adding 2 every time, and if you're using the previous term, it is times 2. So it is counting by 2. And it's also the odd numbers, 3, 5, 7, 9. So we could say that the pattern is odd numbers, and it's increasing by 2. My next term then is going to be 11. 3, 5, 7, 9, 11. And the rule that's going to go with this, we have to look at, if I plug in 1, I get out 3. If I plug in 2, I get out 5. If I plug in 3, I get out 7. So how are these numbers related to one another? If I plug in 4, I get out 9. Well, increasing by 2 tells me that I'm going to be multiplying something by 2. So I could take 1 times 2 and I'd get 2. 2 times 2, I get 4. 3 times 2, I get 6. 4 times 2, I get 7, or 8, I mean. And these numbers here are really close to these numbers here, except for that I need one more, so plus 1 on each to get to the next ones. So my rule is actually going to be 2 times n and then plus 1. And so I could find my fifth term. I said it was going to be 11. So my fifth term, if I plug in, make sure that it works, plug in 5 for n, I get 10 plus 1, which is 11. So I noticed that my n's were doubled and plus 1 more. And so that's how I can write my general rule. It really takes some practice trying to figure out what the pattern is and how to get from each one. So really the only way to get better at this is just to practice it. Okay, in general, if you have something that has fractions in it, I think it's easier to recognize a pattern if all of the numbers are written in fraction form. So we have 3 halves, 3, 9 halves, 6. So I'm dealing with halves. So I'm going to change 3 into halves, and 3 is the same thing as 6 halves. And 6 is the same thing as 12 halves. If I change it back into fraction form, now I'm going to write this pattern over up here to the side. 3 halves, 6 halves, 9 halves, 12 halves. Now I can see that the 2 is staying the same in the denominator. And so really, we're adding 3 on the top, adding 3 every time. Or in fraction form, we're adding 3 halves every time. So that's my pattern. I'm adding 3 halves each time. So adding 3 on the top over 2 on the bottom. So then my next one, 12 plus 3 would be 15. So 12 halves plus 3 halves would be 15 halves. Now to write the rule for that, when you're adding 3 halves every time, you're actually multiplying the number, the n term. So remember, this was n equals 1, n equals 2, n equals 3, and n equals 4. So when n equaled 1, a sub n equaled 3 halves. So what can I do from 1 to 3 halves? Well, I can either add a half to it, or I can multiply by 3 halves to get from 1 to 3 halves. Adding a half doesn't work for the second one. When n was 2, I got a sub n was 6 halves. So 1 plus a half is 3 halves, but it doesn't work for down here. 2 plus a half is not 6 halves. So the only other thing to get from 1 to 3 halves is to multiply by 3 halves. Does that work down here? Multiply by 3 halves, I would get 6 halves. So my general rule for any n would be 3 halves times n, so times the term number. So if I wanted to find the fifth term in the sequence, which I said was 15 halves, I tested out is 3 halves times 5 equal to 15 halves. Remember, you can multiply a whole number by putting it over 1. So we get 15 over 2. So it checks out. So that's your general rule for that sequence. All right, the next one over here, 1, 8, 27, 64. Hopefully you recognize those numbers. Those are all perfect cubes. So in the numerator here, we have perfect cubes over, and on the bottom, 2, 3, 4, 5, starting at 2, but then we're counting by 1. But remember, we have to compare this to when n equals 1, or when n equals 2, n equals 3, n equals 4. What does a sub n equal? So I like to look at the first one here. When n equals 1, I get 1 half. And I knew that they were perfect cubes. So my next term, my next perfect cube is going to be 125, and 5 plus 1 is going to be 6. Now for my rule, I know that 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So notice how those numbers, these 1, 3, 2, 3, 4 corresponds to my n equals. So on top, I have n cubed over, then when n is 1 on top, when n equals 1, I have 2 here. When n equals 2, I have 3. So on bottom, I have n plus 1. I have 1 more. So if I want to check my fifth term, I'm going to have 5 cubed over 5 plus 1. So this is going to be 125 over 6. So that checks out. This might be slightly confusing. I understand that. Really, the best thing to do is get practice. And remember that we're inputting n's and outputting a sub n and trying to find the connection between when n equals 1, a sub n was 1/2. When n equals 2, a sub n was 8 over 3. So trying to find the connection between the n and the a sub n. Like when you're trying to find the connection between x and y, input, output. Very similar idea there. It really just takes practice in recognizing those patterns. I think that's it.